So the topic today is cloud and how applicable is it, how ready is it commercially to be leveraged for delivering healthcare solutions. And I have been in the business of delivering enterprise applications for the past 10 years, and increasingly cloud computing is figuring in solving the infrastructure part of enterprise applications. So what is cloud computing? A lot of definitions on cloud computing floating around, and the definition that makes the most sense to me is it's simply a set of pooled computing resources and services delivered as a service over the web. Now what does it mean? So I'm just going to take an analogy and explain what cloud computing is. We all use web-based email day in and day out. Right? I mean, almost on a day-to-day basis, we used web-based email. In the early 1990s, right, if you want to consume email, the only way to do is install a thick email client like Outlook or Thunderbird, configure it to talk to a back-end email server like Exchange. You have to monkey around with ports and protocols like POP3 and IMAP and all that. And then having done all that, you can consume your email only from that computer, right? If you're traveling and if you're in front of another computer, you're out of luck. You can't access your email. Not only that, let's say Microsoft comes out with Outlook 2007, you are responsible for upgrading it. There's a security patch out by Microsoft, you are responsible for installing it. And let's say you're pulling important Office email into your Outlook client, you are responsible for backing it up. So you have to manage your email client and your email environment. Then Hotmail came in the early 1990s. To me, Hotmail was the first software as a service that was a critical success, right? And now if you want to consume email after Hotmail, you can just fire up a browser anywhere in the world, wherever you had internet connectivity, punch in your username and password, and while you have email. And they took care of backup, they took care of antivirus, they took care of software upgrades, and all you need to do was log in. And you need a browser and internet connectivity. Now that is software as a service. Now let's say you're in the business of deploying an enterprise application, right? You need a computing infrastructure to deploy your application. What does infrastructure mean? You need servers, right, to run your app servers and web servers and whatnot. You need a database engine to persist your data and run your queries. You need a ton of storage, right, for storing things like your file attachments. Maybe you have digitalized x-rays and scans. You have historical patient data which you have scanned. So you need a ton of storage. You need to store these documents so that you can access them. Without the cloud, the only way to deploy this application is to do careful capacity planning on what are your infrastructure needs. How many servers do I want? What is the storage requirements for the network? Do I need a gigabit Ethernet? What kind of database do I need? And then you have to provision them, install them, do a lot of network magic so that these things talk to each other. And also you need to take care that it's fault tolerant, meaning that if one server goes down, your application is still available, right? You need to make sure it's secure, meaning that you have to apply the latest security patches, you have to harden your OS, harden your database and things like that. Now imagine if you can get this infrastructure provision as easy as getting your email today, right? That is the promise of cloud computing, right? So with cloud computing, as easy as getting email, you can log on to a website like Amazon EC2, specify what kind of a machine you want, right? You can say that I need a machine with dual-core Xeon processors, I need 8 gigs of RAM, I need about 500 gigs of storage, I need gigabit connectivity, and give your credit card, and within an hour you get your instance up and running. A very highly available, stable instance available to you within an hour. Compare this to traditionally provisioning infrastructure, and it's mind-boggling how easy it is to deploy applications using cloud. So Amazon is the pioneer in the cloud technology. So they came up with EC2, which stands for Elastic Cloud, and they also came up with S3, which is a cloud storage instance. And what they're promising to do is trying to deliver infrastructure as a service. I think Microsoft is investing close to $1 billion in their Azure platform, so which means that they're really believing in this technology. Various types of cloud, and one is a private cloud, which is a cloud you set up in your intranet specific to your enterprise using platforms like Eucalyptus, right? You can set up something similar to Amazon EC2 internally in your enterprise. There is also a public cloud, which is more prevalent today, which is Amazon EC2, RightScale, Rackspace, Microsoft Azure. There's a multitude of vendors who are offering cloud infrastructures in which you can just give your credit card and get instances provisioned for you. Increasingly, there's also a third type of cloud which is becoming popular, which is a hybrid cloud, which is a combination of private and public. And where it is becoming popular is mostly in the storage area. I mean, I'm sure in due course it will be used for computing also, but today for storage, they're deploying solutions which is a combination of private versus public, right? What are the typical characteristics of a cloud computing environment? I already talked about this. It's on-demand self-service. If you want an instance today, you don't need a big sysadmin team to provision a server for you. You log on to EC2, you punch in a credit card, you pick an instance type, like you can say small, medium, large. You can customize it further. You can pick an AMI, which is an Amazon Mission Image, which says that I want a Red Hat Enterprise 5 at this level with probably MySQL 5.1, and within an hour, you can get your instance up and running. It's dynamic. Again, what I mean by that is you don't have to do very strict pessimistic capacity planning. I mean, typically when you're doing capacity planning and you're buying a server, you think that, oh, you know what, if I need about 4 gigs, I'm going to get about 16 gigs or 18 gigs so that, in my peak volume, will be addressed. And most of the times you'll be utilizing less than 5% of your computing resources. Whereas you don't have to do that with cloud, right? Because programmatically you can kick off more instances. Let's say you are running 3 servers to handle your load, and suddenly you're bringing a couple of more branches and the load shoots up. Within an hour, you can just kick off more instances. So it's very, very dynamic. Practically it's infinite. If you're on a public cloud, the number of instances you can spin is practically infinite. It's self-managed. We touched upon it, right? It is not your responsibility anymore. You don't have to have a kick-ass sysadmin team to keep it secure, highly available, fault-tolerant, hard on the OS. It's not your business anymore. If it goes down, who is responsible for it? If a hard disk fails, none of these issues are your problem anymore, which can be pretty liberating and bring down the cost a lot. There is also another concept which is consumption-based billing. It also goes by utility computing. So you don't pay for the whole server, you can pay for what you use, right? It's like a prepaid mobile card. Amazon charges you based on the computing cycles, the bandwidth, the storage per gigabytes. You can just pay as you go, which can be pretty useful, especially if you're starting off. So having said this about cloud computing, what are the common pros and cons with cloud computing today? So because of the typical characteristics of cloud, the biggest pros are that to get started you don't need to provision a big infrastructure, especially keeping your peak load in mind. You can kick off with a couple of servers, probably one to handle your web server and app server, one to handle your database, and often running. And as you see more and more adaptation of your system, you can add more servers. Especially if you are in the business, let's say you're an IT vendor who are developing enterprise applications for healthcare, you definitely can get away with a lot less investment. It's very, very easy and fast to deploy because, like I said, one of the biggest pain points in the life cycle of deploying an enterprise application is the infrastructure, right? You have to plan, you have to talk to business teams as to the anticipated load, you have to work with your security team to get your InfoSec approvals, you have to talk to the vendor to get it actually shipped, you have to provision it, you have to give it an IP address, network magic, blah, blah, blah. So it takes a lot of time to get a solution to market. Right, with cloud, about 20% of the time in the last phase of an enterprise life cycle is cut off. We already talked about elastic. I mean, suddenly if your solution is more popular than your wildest anticipations, still you are safe with the cloud. You can just kick off as many instances as you want, and you are fine. By just the very nature of being on the cloud, it's very mobile. Meaning that your IT team or even your users have access to your servers from anywhere in the world, and it's very secure. For example, on EC2, they give you a secure shell access, which is pretty secure because it's encrypted, and the logon is using a security certificate. It is not username, password-based security. So suddenly your IT team, in the middle of the night, if there is an application downtime, they can log on no matter where they are and access the servers. So these are some of the common complaints or fears people have about cloud computing. And in my experience working with cloud, we have been using cloud for more and more of our projects for the past 3 years. We are actually in the process of setting up a private cloud for one of our customers. And I can safely say that many of these cons are not true anymore, right? But let me just go through it anyway. People are very afraid of security of the data, especially hospitals. Oh, it's my patient records. It's very private. I cannot share it with a third party. Let me tell you, okay, if you have your data stored in Amazon as against in your hospital, I can assure you it's more safe. It's because of the technology, the processes, and the people, right? Amazon is really, really good at what it is doing, right? It sets up servers which are practically unhackable. Okay, the technology part, I mean, they take the OS and they harden it really well so that, the usual security flaws are not there. It's highly faulty. If hard disk goes down, your data will never be corrupted because they have 3 levels of data redundancy, right? And the next thing is processes, right? For example, Amazon and Microsoft and Google, who are some of the people in the cloud business, the process is very stringent. I mean, if you have to change one thing in the process, you have to open up an RFC, there's a change management, there is an, 3 levels of approval process. So it's not very difficult for a malicious employee to go and do something with your data, right? And the people, I mean, it's like almost like getting a military security clearance to work in a data center in Google or Microsoft. You have to go through the FBI clearance, you have to go through a multitude of credit checks. So I can assure you that an IT team in Amazon can keep your data a lot more safer than your local IT department in a hospital, right? It's more of a cultural issue. It's a little difficult to sell it to the management. They're always very protective of their data. But technically, I don't think this is a valid reason against cloud anymore. Availability, right? People say that, the servers are with a third party, what if it goes down? And Amazon does go down, once or twice a year, and there's a big hoopla over the internet, oh, I told you so, right? Amazon is down. And compare it to how much uptime your own server has. Okay, I'm pretty sure your server has more downtime than Amazon. And Amazon has excellent support. It's just not Amazon. Any cloud vendor, RightScale, Rackspace, they have processes and people in place to address the downtime. Let's say hard disk fails, right? They can get it up and running much faster than your IT team can. So I think, again, that's a non-issue. There's just a lot of political noise that happens every time Amazon goes down. Connectivity. Now, in the Indian context, I think this is a valid issue. If a servers are online, pretty much in my company, I don't have a server room. All my servers are on the cloud, right? When the internet goes down, and it will more frequently than not, it becomes a big issue. So I've set up a high-end Cisco router with multiplexed internet connectivity from 2 different vendors. In spite of all that, your servers are going to be unavailable. This is a legitimate concern, especially if you have hospitals in tier 2, tier 3 cities, and you need connectivity, that is a real issue. A private cloud might be a solution here, right? Cost. I've been keeping a close tab on what it costs me to run a cloud instance 24/7 for a month, as against having a dedicated server. Because of the heavy competition between cloud vendors, the costs are coming down drastically. But still, as of today, running a cloud instance on a 24/7 basis is slightly about 20% more expensive than having a dedicated server. This is just the server cost. But when you are computing the total cost of ownership of a server, you do have to take into consideration the money you are paying your IT team for the upkeep, installation, upgrades. I think it almost breaks even, Okay, especially if you're in the business of hospitals, you should be focusing on business solutions and not on infrastructure.